All right, let's dive into something pretty mind-blowing today. Quantum computing. We're going deep with this excerpt, quantum computing, the technology of tomorrow. We'll unpack what it is, how it could change things, and the challenges it faces. Things like, could quantum computing actually help us cure diseases like Alzheimer's? Or make financial markets more predictable? Stick with us and you'll find out.
Yeah, quantum computing, it's not just about speed. It's a whole different way of thinking about problems. Problems that would take classical computers, the ones we use every day, thousands of years to solve. Quantum computers could potentially crack those in, well, maybe hours.
Wow, so less like faster horses, more like inventing the airplane.
Exactly, it's a paradigm shift. The excerpt starts by comparing classical computers. They use bits, which are like on or off switches.
Right, like a 1 or a 0.
Right, but quantum computers, they use qubits.
So more like a dimmer switch then, with a whole range of possibilities.
Perfect analogy. That in-between state, that's what we call superposition, and that's where the power comes from. Think of it like a spinning coin as both heads and tails at the same time until you stop it and look.
Whoa, okay. And then there's entanglement, where these qubits are linked, even across huge distances. What would instant communication even look like in the real world?
Entanglement, that's where things get really wild. Two entangled qubits, they can influence each other instantly no matter how far apart they are. Imagine sending data across the globe without any lag or risk of being hacked. That's the potential of entanglement.
That sounds like something out of Star Trek.
Oh no!
Okay, so we got these crazy concepts, superposition and entanglement. But how does this actually impact our lives? The excerpt starts with healthcare and drug discovery.
Imagine scientists could design and test new drugs super fast and really precisely by simulating how molecules interact at the atomic level. We could be talking about personalized medicine, tailored to your genes, maybe even cures for diseases like cancer and, Alzheimer's.
Personalized medicine, that would be revolutionary. And what about finance? Quantum computers could analyze tons of data and predict market trends in real time.
Yeah, think about it. Financial institutions could maybe predict market crashes, make way better investments, and manage risk like we never could before. It could completely change how we understand financial markets.
That's a lot of power, potentially. What about artificial intelligence? The excerpt suggests quantum computing could create AI that learns incredibly quickly.
Yeah, imagine AI that can process information and make decisions much faster than any human, leading to huge advancements in things like natural language processing, image recognition, self-driving cars that can handle any situation.
You could be talking to AI like it's another person, where doctors could use AI to get super accurate diagnoses just from looking at medical images. But all this processing power, doesn't that also raise some concerns? What if AI, powered by quantum computing, could get past our best security systems? That brings us to cybersecurity.
It's a double-edged sword, absolutely. Quantum computing could give us unbreakable encryption, but a powerful enough quantum computer, it could also break the encryption we use now, putting everything at risk, from online banking to national security.
So this amazing tool could be used for good or for bad. The excerpt also talks about some of the challenges in building quantum computers, like keeping those qubits stable.
That's one of the biggest hurdles, those qubits. They're so sensitive. The tiniest change in temperature or vibration can mess them up and cause errors. Imagine a qubit is like a delicate snowflake. Too much heat, little bump, and it melts, causing the calculation to go wrong.
So building and running these quantum computers, that's got to be incredibly difficult and expensive.
Definitely. And then there are the ethical questions, the potential for misuse, the risk of making technological inequality even worse. If only a few people or organizations have access to this technology, it could create a huge power imbalance. Exactly, if we don't figure that out now, it could create a future where only a select few benefit from this technology. And that leads to another challenge. The excerpt talks about the global race for quantum supremacy. The U.S. is in a good spot right now, partly because of government funding, things like the National Quantum Initiative Act.
Sounds like we're ahead, but for how long?
Yeah.
The excerpt mentions China is putting a lot of resources into their own quantum research.
It's kind of like the space race back in the 20th century. The stakes are huge. Whoever gets there first could control technologies that change warfare, espionage, even economic dominance. Imagine a country that can break any encryption. They could completely cripple their enemies' communications and financial systems.
It's kind of scary to think about. So with all this potential and all these challenges, when will we actually see practical quantum computers? Ones that can do all the things we've been talking about?
The excerpt says it'll probably be decades before we see widespread use. We're still in the early stages, figuring out how to actually build and control these crazy, complex machines.
So no quantum-powered smartphones next year.
Not quite. But researchers are getting closer to what they call quantum advantage. That's the point where a quantum computer can outperform even the most powerful supercomputers we have now.
So like when airplanes got faster than trains were still useful, but it was a turning point.
Perfect analogy. Once we hit quantum advantage, it means we've moved past the theory quantum computers can start tackling real-world problems. But even then, widespread use depends on solving those technical and ethical challenges we discuss.
So quantum computing is a marathon, not a sprint. The excerpt also mentions something called Shor's algorithm. What is that exactly, and what does it mean for things like cybersecurity?
Okay, so Shor's algorithm, it's a quantum algorithm that can factor huge numbers way faster than any classical algorithm we know of. And that's a big deal for cryptography because a lot of our encryption relies on how hard it is to factor those big numbers. If you had a powerful enough quantum computer running Shor's algorithm, it could potentially crack those codes, making all that sensitive data vulnerable.
So it's not just a theoretical threat, it's a real possibility our encryption could become useless. What would that even look like?
The implications are huge. Think about it. Financial transactions, government communications, even personal data, none of it would be secure anymore. It really highlights why we need to develop quantum-resistant encryption, to protect our data in the future.
It's a sobering thought. This deep dive has been pretty incredible, learning about quantum computing, these mind-bending concepts like superposition and entanglement. We've explored its potential in healthcare, finance, AI, and we've talked about the challenges and ethical considerations too.
It's a field that's both exciting and a little scary, but understanding this technology is essential for the future. Knowledge is power, right?
We focus a lot on the good stuff, but what about the potential downsides? Could quantum computing be used for bad things?
That's a valid concern. Like with any powerful technology, it could be used for harmful purposes. Imagine someone using it to break encryption for espionage, sabotage, even to disrupt things like power grids or transportation systems.
It's like the saying, with great power comes great responsibility. So how do we make sure quantum computing is used for good?
We need a global effort, to develop ethical guidelines and regulations for how we develop and use this technology. Things like data privacy, security, making sure everyone has access to it, that all needs to be addressed.
But we need to start thinking about this now, before it's too late. This technology is moving fast. We need to be ready for the challenges and the opportunities.
Absolutely. The decisions we make now will shape the quantum future.
We've covered the potential, the challenges, the ethical stuff. But what does it all mean for the average person? How will quantum computing impact our lives in the years to come?
It's tough to say exactly when, but it's safe to say quantum computing will have a huge impact on our lives in the coming decades. We'll probably see breakthroughs in medicine, material science, artificial intelligence, things that will change our world.
It's an exciting time to be alive, that's for sure. This deep dive has definitely given me a lot to think about, and I bet our listeners are feeling the same way. Yeah, it does feel like we're on the edge of something incredible. This excerpt ends with a really thought-provoking question. If quantum computers could solve one major global challenge, what should it be?
Wow, that's a big one.
Yeah.
There are so many possibilities. We could be talking about wiping out diseases like cancer and Alzheimer's, or tackling climate change with new clean energy technologies, maybe even solving the mysteries of the universe.
It's almost too many options to think about. Should we focus on healthcare first? Or the environment? Or should we push the limits of what we know about the universe?
Each path has its own challenges. Like, imagine if we cured all diseases, what would that do to the planet's resources with so many people living longer? And if we tried to solve climate change by geoengineering the planet, what unintended consequences might come from that? And unlocking the secrets of the universe, are we even ready for what we might find?
It's mind-blowing to think about the power this technology could give us and the responsibility that comes with it.
It really is. The decisions we make about quantum computing now will impact generations to come. We need to be very careful and thoughtful about how we move forward.
We can't just focus on the good stuff. We have to consider the potential risks too.
Exactly. We need open discussion and collaboration. People from different fields need to come together to guide how this technology is developed and used.
It sounds like quantum computing is more than just a new technology. It's a societal shift that requires a lot of thought and collaboration.
I think that's a good way to put it. Quantum computing could change our world, but it also comes with big challenges and ethical questions. We need to work together to make sure we're using it responsibly, for the good of everyone.
This deep dive has been a wild ride, exploring this amazing and complicated world of quantum computing. We've covered the basic ideas, the potential to change different industries, and all the ethical dilemmas it brings up.
This is just the beginning of the journey, though. There's so much more to learn about this fascinating field for those who want to dig deeper.
So, as we wrap up our deep dive into quantum computing, stay curious, stay informed, and stay engaged. The quantum revolution is just starting, and it's a journey full of promise and uncertainty.
Who knows? Maybe one of you listening will be the one to make the next big breakthrough in quantum computing.
That's all for our deep dive into quantum computing. Thanks for joining us, and until next time, keep exploring.